Hello, Mr. John. Please just confirm if you can hear me. Welcome. Okay. All right. Welcome, everybody. Please confirm if you can hear me, please. Can you hear me? Okay, nice. Okay, so Michael can hear. Sorry, please. I had an issue with the previous link, so I had to quickly create another link so that we can get started. So, if you can hear me, I think I'll just get started. Well, I guess since one person can hear me, so the others that have joined can also hear me clearly. All right, so you're welcome to this AMA session. Um, the title says "Ask Me Anything." Well, I'll try to answer your questions as much as I can. I don't have all the answers in this world, but I'll try and answer as okay. So I think you can communicate via chat basically. So this is I can speak, you can hear me, but I don't think you can't necessarily hear me. So I think is the voicing is from my side to yours, and then we can communicate via chat. So yes, so I'll try to answer questions as much as I can. Um, I think let's just get started. So for the benefit of those that will be joining later or be watching this video later, I think it would be nice if you just comment maybe where you are joining from. Obviously, I'm in Nigeria, Port Harcourt to be precise. I'm in Nigeria. So as you join, just please indicate where you are joining from. Okay, so some more persons are joining. So I'll just go ahead and kick off the session. So this is ask me anything about AWS cloud and then serverless computing. So I'll just go ahead and introduce myself. My name is Charles Allison. I'm a software engineer. I'm also an AWS community builder. So basically, what we do is try to help people get acquainted with AWS technologies, AWS services, and help them learn how to use it. Of course, we share what we've learned through um, meetups like this, or through their blogs or articles, or sharing simple what do you call it videos, meetup groups, and the rest. So this is one way through which we share knowledge, help others to realize the benefit of AWS cloud. I've been a software developer for quite a number of years, so I qualify as a software developer as well as a community builder. So for this session, I hope to achieve people getting to understand what AWS is and what serverless computing is. It turns out that yes, yeah, I can see John. You're asking can be recorded. Well, I'll try to make that available. I can't get. I plan to record. How it goes. This is responding to your statement. Blog grammar. Inform and then what serverless computing is. Whatever questions you have around these two areas, basically, you can go ahead and ask questions. So, Blogrammer said he was the first to comment. Oh, well, I hope he's going to be the first to ask a question in the comment section. So I'll just go ahead and while you're doing that, I'll just give a brief introduction or definition of AWS and the cloud. So AWS simply means Amazon Web Services, right? They you know the company Amazon, yeah. So they AWS is a subsidiary, if you will, of Amazon as a whole. In fact, the AWS website is actually a subdomain. So you have aws.amazon.com. So now there are services, web service that are available. You can make use of. You can make use of uh, that are provided by AWS. So because these are available via the web, obviously you have the web preceding the title service. Basically, web services or services that are available via the web for everyone that's provided by AWS. Um, the next question will be what is cloud, because it's always AWS cloud. What is this cloud all about? Well, the services is part of what the cloud is, but let me try to break down the word cloud. Someone said, okay, Blogram, I see your question. So let me just say this. I'll answer immediately. So someone said I was in a webinar some 2 years back when someone said um, he was asked the question, and the question was what is cloud, and then the response was the internet is the cloud, right? So of course a lot of people confuse what the internet is and what cloud is, and sometimes just put them together, but they are different, right? They are different. So let me start by saying some persons will say the cloud is someone else's computer. It's beyond that, right? It is really beyond that. The cloud is services, web services, um, being provisioned as a pay as you go, in a pay as you go way. So you want to set up a kind of VMware or a virtual machine. You want to put up some kind of um, dev environment for your developers to be able to try out something. Not really. You're not. This is just a test, right? You're not going to production yet, and then you want a situation where you have that environment up and running for devs to try something. So you want to be able to just quickly set that up, and maybe if it doesn't go through, you maybe the idea doesn't go through, you want to trump that, and then continue with whatever you want to do, and not minding uh, how much you're going to spend, because you only spend as per your use. So you're not thinking of buying, maybe shipping or ordering some very large servers just to test out that feature. So basically, it is compute and a number of other services put together that is being offered via the web. Makes it easy. It makes it thoroughly easy. Um, you can see there are many definitions online, but what I'm trying to do here is break it down into very, very simple language that everybody can understand, because I believe we won't be all the folks that will be joining won't be all technical guys. So I'm trying to break it down as much as possible. Okay, so let me jump right into Blogramma's question. What are the limitations of serverless computing? That's a strong one. So initially, when serverless was introduced, there were some people kind of believed that, oh, this couldn't do this couldn't do this, it couldn't do a lot of things. That was when it was introduced. But right now, I can tell you, I don't know of any limitation, so to speak. Your Serverless, I think the most important thing here is to understand what serverless actually is. Once you can understand that, then you may not really be thinking in terms of limitations. um, because it takes one of the most important attributes of serverless is the fact that it takes the hard work, the big deal out of running your service online. It takes that major work off you, right? So you can focus only on your product, only on your business logic, right? So, in answering this question or giving some kind of guidelines, let me go back or let me try to reiterate what serverless computing is. So, traditionally, what you do is you have to send, maybe buy a server somewhere, pay for it, maybe you specify the size. I want a 10 gigabyte hardware, and then I want a situation where, okay, I want Windows installed on it, or I want a Linux OS installed on it, and you give all those specifications. And then when your business grows, let's say initially you were receiving 5,000 requests, and then the server was able to handle that. Now imagine a situation where you're receiving 100,000 requests in a short time, and you know that you begin to experience a lag, so to speak. Latency becomes an issue. So what you do traditionally is you have to buy another server and try to do some um, expand your service across those two hardwares. Now, what serverless does for you is it takes off that big deal, that burden of having to manage servers from you. So what you do is you write your code, your business logic. Let's say it's a simple. I'm sending a request to retrieve the number of let's say persons on this chart. So after I send that request, I get my response. So if I have 10,000 requests going for the same endpoint, then what happens? What serverless does is serverless on its own automatically expands, or better put, it creates more handlers, if you will, to respond to the number of requests so that it can accommodate all of that without you, the programmer, having to do anything. So, of course, there are servers behind the scene, but that the management of the server has nothing to do with you. In fact, you are not the one managing it. So all you do is you write your code and then you deploy. In fact, it's something, if you've heard of the term function as a service, right? That's what function as a service is. So you write a simple function, maybe one function or two or three, as much as your business requires, and then you deploy those functions. So it's similar to when you're designing or developing a microservice application, right? So you deploy just one function, and then that function can automatically scale with respect to the number of requests it receives. So serverless is that idea that you don't have to manage that. So if you think of it in this way, in this light, it's like it's almost, or you say it's kind of limitless, because what can you do or with managed service that you cannot do with an unmanaged service, if you get the point. So uh, the limitations don't really I've not read, of course there are issues, but I've not read of any real limitation, so to speak. And by the way, there are more services that come up that supports serverless computing on AWS. So you don't really look at in terms of limitations. You look at what can I not achieve, right? If you understand the question. So serverless computing is basically, you don't have to manage servers. You focus majorly on your business logic, deploy the code, and then you're good to go. You just do some configuration with respect to your code. For example, if you're building a microservice application, you will be responsible for um, deploying and configuring your API gateway. Now, your API gateway is what makes your microservices look like there's just one application. But of course, we know, of course, it's like more than one application. It can be 500 microservices or up to 1,000, or as the case may be. So your API gateway makes all those different programs, probably running on different machines, act as though it's one. Now, if you're doing that on your by yourself, you have to configure it, install it, and then configure it to map out to the different services. But if you're using the equivalent of a gateway, which is called API gateway in AWS, um, you only need to just configure, okay, hey, this is the route I want, and then I'm mapping this route to the actual function that will handle this request. That's basically what you do, right? You create on your in your API gateway, you create a route that links to the function that handles the request for that route, and then you're good. Whatever request that comes in, the server knows how to automatically scale. If you have 5,000 requests, the server knows how to automatically scale so that you can handle requests from your users. All right. So I hope that's clear enough, Mr. Blogrammer. Just let me know if you're clear or if you want further explanation. What I'll try to do here, you still have more questions. Go ahead, drop your questions. What I'm trying to do here is I don't want to go too technical because of what do you call it, the audience that we have, because I've already mentioned a lot of things, microservice, API gateway, so I'm already feeling a bit guilty. But yeah, so maybe what I'll do after the session is I'll see if there is some more time, then I can go in for more technical questions. So please go ahead, ask, drop more questions. If you have, if you don't have, we can go on with. Uh, so, Blogrammer, I think you should just go ahead since we are not seeing any more questions. And you don't have to wait for me to get done. You can just go ahead, drop your questions. As I get done with a particular question, I'll get into the next. I'll get into the next one. So I get done with answering anyone that is there. I'll go ahead with the next. All right. Okay, so this is purely technical, but well, I'll go ahead and answer. So, how do you migrate an existing application to a serverless platform? So, first of all, you need to understand, is that application a monolith? Now, monolith simply means it is your application, your entire applications. Uh, in maybe I'm a Java developer, so whenever we build Java applications and then we build it and we try to deploy, we can deploy either as a jar file or as a WAR file. So now imagine writing a very complex and a large application in just one file. So what you have to do first of all is to look at, okay, is this a monolith or is this what do you call it, a microservice? Now, if it's a monolith, one of the things you have to understand is serverless is it's kind of it's similar to microservice in the sense that it is small chunks. Now, microservice is like a whole service, say in a shopping site, for example. I can have a user service that just handles user login only, or I have a cat service that just handles the cats for every user that is logged in. So I'll have to split my monolith into lines of services, right? So I have to identify individual services in that monolith application I have, since it's a monolith, just as it's written here. So I have to identify that. Once I can identify that, I can then start bringing out the service, the functions, so to speak, because serverless has to do with functions. So of course, functions are functions within a bounded context, if you will. So you now identify all of those and then start rewriting in quotes, writing what you need, writing them into a serverless application. That's not an easy one. People consult majorly for migration purposes, right? It's one of the big deals because it's you have to take the time, go through whatever applications you have. If you have monolith applications or you have microservice application, you have to take the time to now break down all your functions, or like I said, divide it between um, service lines, and then try to bring out the functions that all the services have, and then you can now start translating them. And like I said, it's not an easy stuff, uh, but of course it's been done. Yeah. All right. So I see Aku Michael. What services are useful in AWS for building machine learning models? Okay, AWS has a number of services for building machine learning models. I personally am not a machine learning engineer. Um, what I can do is there are services. I think let me just get the link. There's AWS services that uh, you need for machine learning. So AWS machine learning. So I'll drop the link so you can using what do you call it? Using You can filter by machine learning, or I'll just drop this link. Okay, so while I look at that, so Programmer says if I have 10 endpoints, do I have to deploy the individual endpoints separately or deploy one function to act as a gateway to other endpoints? Oh, okay. So it's up to you, right? It's up to you. But of course, you don't want to bundle everything together, right? What this simply means is if you have if you have um, if you have one function to respond to every other, if you have one endpoint to respond to every other function, it means in your statements you now have if else, you have lots of if else depending on how large your application is. You have lots of if else statements, right? To now say, okay, what part is this, or is this, does this have a query parameter? Because you have to do all of that to check which particular function you want to call. Well, you be the judge if you want to do something like that. But of course, if it's a large application, I wouldn't advise for that. Before I go to Michael, I think John's programmer's question is related. If they are related, you might want to bundle. Well, like I said, it's you be the judge. If you think it's related, okay. Now, bear in mind that if having if else statements in your application is not a crime, but where it's unnecessary. Come on, when you have like 1,000 if else statements, or you have nested if else statements, I think uh, I believe you can you can look at some other ways of refactoring your application so that it's easily maintainable. Because what you want to avoid is the fact that if you want to update a particular function, you don't want to drop all your other functions just to update one function, right? You don't want to have you don't want to say you're building microservices or serverless application, and then you're still building with the mindset of a monolith, right? It really doesn't make make any sense. So personally, I would advise that you separate them. One thing also I think I should make note of is every function is expected, is advised that you have every function in different files. You may have them in the same application. Of course, the deployment model is such that every function, right, is deployed as its own. So if you want to take down one function, you can take it out without affecting the others. But if you have it nested, whether they are related or not, of course, whatever you're doing on one is going to affect the child of the other. Okay, so I think I've answered this. Yeah. So yeah. So can you explain communication between two different microservices using AWS, synchronous and asynchronous? Okay, so this question has, okay, so let me put it this way. So first of all, we want to understand communication, the different types of communication as listed here. We have synchronous and asynchronous. This is without AWS, right? So first of all, synchronous means I send a request. Until that request comes back, I'll be waiting on that request, right? The sender will be waiting on that request until the result or the response for that request comes in. Now, asynchronous is quite opposite. So you send a request and then there's no waiting, so to speak. Those kind of when you think or when you design applications like that, you're going to what's called event-driven architecture, right? So you're saying, okay, just raise an event. If it's whoever that is responsible for handling that event is going to respond to that event, and then when it's done, another event will be raised. More like, okay, hey, I'm sending you a request event, and then whoever function is responsible for that event request is going to receive that notification, perform whatever logic it has to do, and then raise an event with the response. So of course, whatever function you have that is also listening for that response event will be notified when that event is raised. Now, there are different ways you can communicate across services in a microservice architecture. You can do a direct communication, which means you do your normal REST communication. So you send a REST call, REST request. And then obviously we know that depending on how it's written, it is it is synchronous, right? Now, what you want to do is the other one, I just explained REST. So the other one is maybe using some kind of event bus, which is um, most the one that everyone will advise you to go for, because you don't want a situation where a request has been sent and then the sender is waiting for the response, and then maybe that service goes down for some reason, or maybe the logic is taking so much time and it goes down the response doesn't come immediately. So you don't want a situation where the requesting service is on lockdown, cannot receive any more requests because is waiting for response to come in. So what you can do is you can use event system. So you can use AWS has a queuing system. It's called SQS. So what you can do, you can send the request to a queue, and then the service that needs that can pick it up from that queue, or you can use the event bus that AWS provides. So when you have this, you kind of detach. You don't have services that are coupling, right? So maybe I think I should mention this, that if you're doing a REST call, you are binding or you are coupling services that are not supposed to be coupled. Remember, you're designing microservices, right? You're designing microservice applications, so you shouldn't think of the coupling. So you should think of how to make sure a service runs without having any issues from, even though they are communicating. So AWS has, you have SQS, which is queue, and then you have the event bus in AWS to help you with with uh, that communication. It's called AWS. What? Just a second here. Okay. So I don't know if I've answered the question, Mr. Aku. You can comment and let me know. So let's get down. So yeah, so AWS SQS is one. SQS is one. The other is Event Bridge. Yes, Event Bridge. That's what I was thinking about. Yeah, Event Bridge. So it's they are similar, but you can use them to achieve same thing, but they are different in how they operate. So if the web server is serverless, how about the database? So um, if the web server is serverless, so serverless requires some a different idea to thinking about applications. Um, what you're deploying in serverless is not an application. What you are deploying in serverless is a function or functions. Now, the way you deploy your, okay, let's say maybe you have a monolith application. The way you deploy that whole bundle of application, now when it gets to microservice, you know that's not how you deploy, right? Now, serverless don't really have servers, so to speak, right? They don't really have web servers. They have an executing environment. So you can say, hey, this my function is written in Node.js, right? This my function is written in Node.js. Maybe if it's version specific, it's written in Node.js 8 or Node.js 16 or Node.js, whatever version is written in, right? And then you deploy that function. Now, that's your configuration for your executing environment. It's going to set up whatever it needs to set up for you. And I may be going too technical if I start telling you about how the execution environment is being formed and how it is destroyed after every execution. Let's say after a given period of after execution, after a given period of time. So let's say I make a request. At the time of that request, when the request is made, my function has to be initialized. That is when the environment that runs my function is created. So that environment is created on request, right? So after it's being created, the function executes. Now that environment stays active for a while so that if another request comes, it can use that same environment, right? That same function that is existing to run, to respond to that request. But if the time elapses and no request comes in, that environment is going to shut down. If another request comes in, a new environment is going to be created again, right? So that's how serverless works. Right? So it's not really a web server specific kind of thing. It's called an execution context, and that part is not really handled by you. Now, on to the second one. How about the database server? Yes, you can use whatever what do you call it, database you want to use, but it is most advisable to use AWS database called DynamoDB. Now, DynamoDB is also a managed database. What happens is you don't need to do anything about the setup, about how to handle how many requests that comes in and all of that. You really don't need to do all of that. So what you need, what's you're concerned about is what you're concerned about is setting up your schema, the structure, how you want your structure to be. Of course, it is a document kind of DB. So you just set up what you expect, how you expect your structure to be, your document structure to be, and then you go on and save whatever you intend to save. Right now, you can also use what do you call it? You can also use other database engines. MySQL, Postgres, AWS actually has an offering for it for them. That's RODS. You can also use that, but it's most advisable to use DynamoDB because it supports lots of the features that a serverless application would require. So I think I explained a bit about the web server and the serverless, how the architecture actually of the execution. And then I mentioned about DynamoDB. So I don't know if that's clear. If you want us to go more into that, you can just go ahead. So let's get on to the next question. Is serverless really cheap? Considering the long-term use, pay as you go can also become expensive over a long period of time. Okay, so your other statement is the second statement is a little bit tricky. So pay as you go can become expensive. The question is how. Anyways, let me explain about serverless being cheap. Serverless is really cheap. In fact, serverless is like an umbrella name. AWS offering for serverless computing is called AWS Lambda. AWS Lambda. So so if I can use it interchangeably. So if I say serverless, I'm also referring to Lambda service in AWS, right? Of course, I'll be discussing AWS. So the major or the primary or the first service that you can think of when you think of serverless is AWS Lambda. You have AWS Fargate, but that's majorly when you're trying to containerize your function and deploy it as a container in, of course, Docker. So is serverless really cheap? Serverless is really cheap. Really, really cheap. Now, I was involved in a project that was in 2019, just before the pandemic, and we were supposed to develop some kind of application, ride hailing application. It's slightly different from that of Uber. What they did, you have this card, you have a card, and then you swipe it to pay your fare. So yeah, here in Nigeria, so we developed the application. Now, before developing, we were ready to start. We had seen everything on ground and everything, the plans and the business case and all of that, and we were ready to kick off. But what happened? We couldn't really do so much because the guys wanted to deploy on a what do you call it? Their own server, right? Their own server. They didn't want to deploy to the cloud. So what happened? We had to wait. That's time. Of course, you're looking at cheapness now, but let me go ahead. So that we had to wait until the server came in, right? Now, when the server came in, we had to start installing different things. Now, take note, if it's in a very large organization, you want to make sure you have, or even it may be large organization or it may be just a startup. You want to make sure you have the what do you call it? You want to make sure you have the right hands, so to speak. You want to make sure you have experts, so to speak, that can handle these things without any mistake. So you will pay for those guys to come in, and then you're talking of DevOps engineers, SREs, site reliability engineers. You have all of them. This is some of them don't even do as much development, right? Because of course you want them to focus on whatever they do. So by the time you're done with all of this, you need to pay experts that have very good idea in Kubernetes, containerization, and all those things. Now, by the time you're done doing this and trying to set up, you have to pay. Take note, you've not even gone to production yet. You've not even launched your application. This is just test. You just want to run a test. And so this is exactly what happened in that project I was working on. after everything, okay, so for some reason, I always developed in the night, maybe around 12 a.m., 1 a.m., 2 a.m. So I had to they had to make sure the server was on for me to test whatever I was doing. You see, and what happened? Um, in some organizations, especially in some countries, some African countries where power is a thing, is an issue, you have to maybe get some alternative power source, um, get a generating set, and all those things. That is outside the cost of your product actually going live. So they had to make sure all these things were available for me to run whatever test I was doing. Take note, we were still in development. Now, if I was doing serverless, the only thing I will care about is my functions, is my business logic. I wouldn't bother to think about the server. Okay, if it goes down, what do I need to do? And take note, you have what do you call it? You need to have folks around 247 to make sure maybe some hardware issue doesn't happen and all of that. But in the case of serverless, this is handled for you, right? There is let me see if I can find it. There is an article by Coca-Cola. Coca-Cola was spending okay, so Coca-Cola was spending about $13,000. I'll just put up the link here. So Coca-Cola spent 13,000 annually to maintain whatever infrastructure they had, right? To run their service, to, to be live. Now they moved from whatever they were doing to serverless, and guess how much they were paying annually? That's $13,000 that they were paying annually dropped to 4,490 annually. This is, let me just, so you can read the article there. So serverless is really cheap. Is really cheap. Okay, so how do you optimize the cost of running applications on a serverless platform? Okay, so there are quite a number of things that you can do. You can be looking at, first of all, you have the idea of cold stats, which I think I saw somewhere down. You have the idea of cold stats. You also have the idea of concurrent usage, right? You have the idea of concurrent usage. Um, you also have a number of things that you can look at. You can look at the timeouts. You can look at memory as well. So all these things are configurations that you can use to optimize the cost. Of course, I think I should mention that you are only charged per request. So if you build an application and nobody uses the application for a whole month, you won't pay anything for that month. That's the big deal about serverless. But if you compare it to something else, maybe to a hosted service like maybe Kubernetes and the rest, you will definitely have to pay. Whether a user comes in or maybe user uses the application or not, it doesn't matter. You will have to pay. So maybe you can go to there are several use cases where there was a heavy reduction in cost. A Cloud Guru, if you know about them, they provide cloud training. They were running as big as they were. Their bill, I think their monthly bill wasn't up to $1,000. I can't find that. I tried to look for that article before this session, but I couldn't find it. But if I get it out, maybe in the next offering I'll be able to talk about that. So serverless is really, 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 really cheap. All right, what are the career opportunities available on AWS? Okay, yeah, there are quite a number of them. Um, what I can do. Okay, so let me just try to list the ones I can remember. So you have what do you call it? Technical account manager. You have cloud engineer. You have cloud administrator. You have the developer. You have let me get a link. You have sales executive. You have there are quite a number of them. There are quite a number of them. And besides, this um, AWS is not only technical. Of course, you need some other fields. You need accounting. You need legal. You need several other fields because you'll be dealing with customers, right? Yeah, you need several other fields to ensure you have um, smooth customer base. So I just sending a link. This just has some of the entry level jobs in AWS respect to cloud. So what would you say about cold start? So cold start is basically, I explained the fact that when a function is invoked by maybe a REST request or uh, maybe an based on an event, because you have sources that um, invoke your functions. Now, when a function is invoked, now depending on how you write that function, you're going to have okay. Let me see. Cold start is actually the time it takes the function to initialize. So that case is going to pull in the external sources, maybe external libraries. I mean, external libraries it uses is going to initialize your static fields. Of course, if when writing applications you may have some static fields, those static fields have to run first before the instance, right? So it will initialize all of that. So what happens is if you have so much going on before your function runs, then that will contribute to cold start, right? So before your function actually runs, it will take a long time, right? That's what a cold start is. So is the function is trying to wake up, if you will. Yeah, and this happens the first time, right? Cold start is only the initial time when the function is being invoked. After that initial time, you don't have an issue again with cold start. So, and of course, like I explained earlier on, after when that environment is still up and running, you can send in request without having an issue, right? But when that request has gone down and then there is no other execution environment for that your function, it means it has to create the environment from the ground up, right? So what you want to do is you want to limit so much that you do with respect to um, external libraries and what you do before the function actually runs. It's very you have to take care of that. Okay, so I hope I've answered that. Okay, so this is it always good to dance? Agree. You may have to rephrase the question. Is it always good to dance? Agree to company idea when they claim there is no fund to provision a microservice, but you know that the application growth in the nearest future will require a microservice. This is um I would say administrative question. I, I wouldn't know if the company has the money or has the funds or do not have the funds. So of course that's up to them. And this is where serverless comes in, right? So you want to be able to deploy and test out whatever you have, even without you can just quickly set up your um, write a simple function or write an application and deploy the functions and test out what you have to test out, pending when the company says they have funds for deploying that. So, well, I don't know. So that's what I can say. So if okay, Okay, it also says thanks for this. You're welcome. Um, Aku, I hope I answered your question. It's tailored is towards the admin of a company. So, so I don't know if I've been able to answer um, your questions very well. If there are more questions, we have just a few minutes to go. Um, I actually set up a group for those who are willing to continue from here. Uh, just a second, I'll get that out. Oh, nice, beautiful question. So, how can you monitor and debug applications running on a serverless platform? Okay, so debugging is if you have idea of programming, general programming, you can debug in your IDE. It's as easy as that. You can debug in your IDE. There are frameworks that can help you in your developments for serverless. Uh, Let me get this link. All right. So there are frameworks that can help you to test and then debug whatever you want to do for your serverless applications. Right? Yes, I'm referring to this. And then for monitoring, of course, monitoring cuts across um, monolith applications, serverless applications, microservice applications. Uh, but for serverless, for once you're running on AWS, it is advised that you use CloudWatch. CloudWatch is, in fact, you have what do you call it? The basis for monitoring. The basis for monitoring is logging. So if you don't have logs in your application, you cannot monitor anything, right? So you have to log. You must have logs in your application. And now AWS has a service that collects log. It is amazing. It's just an amazing. It's a CloudWatch, right? You still have CloudTrail, but for as a fundamental logging service, you can you can look at CloudWatch, and once you have CloudWatch, you can then build your own dashboards based on the metrics. Like for example, if you've used Prometheus and Grafana, you realize by the time you do your integration, you just have metrics, you have data coming out. So you have to now build your own dashboard with respect to the kind of data you want to um, collect. So, do you pay for monitoring? Yeah, you pay for monitoring, but it's very, 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 very small fee. A very small fee. Very small fee. And of course, it depends on how you want to monitor, what you want to monitor, and all those things. For example, I know this is about serverless, but if you want to watch your there's some logins that you will need CloudTrail, a service called CloudTrail, to help you monitor, help you get data from it. Uh, that is a different pricing model, I guess, from that of CloudWatch. But as a fundamental, CloudWatch is what you can use to monitor your application. Remember, without logs, you can't monitor. What are some common challenges and pitfalls to watch out for when working with serverless architecture? I think the most important is your cold start, please. Cold starts, long running functions. The three things you should look out: you have timeouts, because your function is not going to run forever. I think there's a limit of 15 minutes. So nobody expects a function to run beyond 15 minutes. So you have a 15 minutes timeout. So you don't want to have a memory, because when your application is running, it needs a memory to keep some temporary data, if you will. So you want to also be aware of that as well. You don't want to specify something that is too large. That's why testing is very important. We've gone beyond the time. So I would like to say thanks to all of you that joined in. I hope this was informative for you. What I've done is I've created a group on Telegram for those that are interested. Yeah, for those that are interested. If you want to learn more about serverless, if you want to learn more about AWS, if you want to learn more about serverless, the cloud, AWS, please do well to join that Telegram link there, so that we can you can maybe meet people of like minds and then grow from there. So I think let me take this last question before I call it a day. So I noticed from your career progression, you are an AWS community leader. How were you able to achieve that? Okay, so you don't really need a special career progression to become an AWS builder. You just need to show interest, and then you need to be willing to share knowledge, right? You need to be able to share your knowledge with anybody, with the community. Just tell them what the services AWS has to offer, and all of that. And I think that's just all. Show enthusiasm, show that you are making some progress towards learning, and then when you apply, hopefully you fall in. Maybe I can send the link. Let me just get the link, uh, so you can visit that link, and then you'll get. Right, so that's the link with respect to community builder. So thank you everyone for joining, and hopefully we'll have a more elaborate section maybe sometime in the future, and hopefully a technical workshop to answer all the technical questions, and even some demo even. All right, thank you so much, and have a great one. Don't forget to join um, the Telegram group if you're interested, so we can continue from there. Thank you very much, and have a great time.